This is walks. He likes reading and holding his tablet. One day he found a false information in the internet which he think is true. When Walks arrived at the school, he excitedly shared the news that he found on the internet with his classmates and believed the information without knowing if it is true or not. That scenario is an example of rumor transmission. Hence, what is rumor? And why study rumor transmission?
A rumor is a piece of information that has not yet been proven to be true but is passed to one person to another. It is a social phenomenon that contains information which lacks a solid basis of evidence. It can also be spread on a daily basis. Studying rumor transmission can lead to a better understanding of their nature. It will also help to analyze how rumors become less accurate as they are passed on person to person.
To further understand rumor transmission, here is the fundamentals of graph theory. This is a mathematical tool that is used to model pairwise interactions between objects known as graphs. In this sense, a graph is made up of vertices, also known as nodes or points, connected by edges, also called links or lines. Network is frequently used to investigate methods for describing and modeling complex networks. Specifically, social networks, where it observes social dynamics by representing the vertices as the people or even groups of people, while the edges represent the connection between those people in that network. So what is a path? A path is a non-repeating sequence of vertices and edges that does not pass through the same vertex. This measures the length of a path multiplied by the number of edges in that path. The general formula for path is L of G is equals to 1 over M multiplied to quantity n minus 1, where M and n is an element of G as the length of the shortest path from M to n, denoted by D quantity, M and n. On the other hand, the clustering coefficients is a measure of the degree in which the vertices tend to cluster in a graph. It quantifies the relationship between a vertex's neighbors. This probability is larger than the average chance of a tie establishing between two nodes at random. Nodes in certain network systems, especially social networks, generally prefer to form close-knit clusters with a dense population of links, per the data. A graph's vertex indicates how close its neighbor is to being a full graph. The formula for clustering coefficient is as follows, where V represents a vertex, kV is equals to its degree, and NV is the number of links between neighbors of V. Centrality is used in analyzing graphs to identify the most important vertex in a graph. The three most common ways are degree of centrality, closeness centrality, and betweenness centrality. The amount of linkages carried by each vertex determines the degree of centrality. To determine the average degree, the formula to be used is D is equal to summation of D over N, where D is the degree and the N is the size of the network. The closeness centrality calculates a score for each vertex based on the total of the shortest paths between all vertices. The formula for closeness of centrality is 1 all over the summation of D multiplied to the quantity of V and T, where V denotes the vertex set and D quantity of V and T is the sum of the distances between vertex V. As a proportion, the calculated value must be 0 less than calculated value and less than or equal to 1. The betweenness centrality calculates the shortest path number of times when the vertices lie between each pair of vertices. To compute the betweenness of centrality, the formula is quantity of n-1 multiplied to quantity of n-2 all over 2. Where n is the number of vertices, then the computed value is the number of pair vertices.
Understanding rumor in a small world network. So, what is a small world network? A small world network is one created from any other form of social network. A small world network is a mathematical graph that means most vertices are also neighbors of one another, but every vertex can be reached from every other by a small number of hops or steps. It had some shortcuts, where vertices represent people and edges connect people that know each other, capturing the small world phenomenon of strangers being linked by a few mutual acquaintances. This implies that every person on Earth can be connected to any other person through a chain of acquaintances. The researchers start with a regular graph shown in Figure A. It is a graph whose vertices have equal degree. Thus, in this regular graph it is 10 vertices and 4 degree edges connecting to each vertex. The degree of a vertex is defined by the number of edges to which it is connected. The researchers start with a regular graph that randomly rewires each edge with probability to create a simple representation of a small world network, which is shown in Figure B. The process of adding edges and cutting edges are the two ways in creating an illustration. Hence, in this, the added edges in B were 7,4, 9,4, 0,4, and 0,9, and the deleted edges were 7,8, 0,9, and 3,6, to create 10 vertices with 4 average degree edges connecting to it. In calculating the clustering coefficients of Figure B, the formula we need is here, where V represents a vertex, kV is equals to its degree and NV is the number of links between neighbors of V. Suppose V is equals to vertex 4, kV is equals to 6, and NV is equals to 4. So the clustering coefficient we get is 0.2667, which is between 0 less than or equal to clustering coefficient less than or equal 1. In solving the degree of centrality, the formula we need is here, where D is the degree and the N is the size of the network. Based on Figure A, to calculate the degree of the small network problem, each vertex must be defined. There are 10 vertices, each of the vertex is equivalent to degree of 4. Therefore, the total degree of all vertices is 40.
Now, let's talk about closeness centrality. To compute, use a distance matrix to put the distance from one vertex to another in the recent figure. Once the distance matrix is computed, get the sum of it and divide it by 1, to get the closeness centrality shown in the table. The individual who is closest to most of the others in the network, meaning that they do not need to go through too many others to get to another specific individual, could also be considered the central node or vertex. Therefore, the central vertex considering the graph in Figure B, is vertex 4 because of having the highest closeness measure. And to compute the betweenness of centrality, the formula below. N represents the number of vertices, which is 10 minus 1 multiplied by 10 minus 2 over 2, which is equal to 36, that means the number of pair vertices. Wherein, the following denominators is the number of shortest pathways connecting pairs of edges throughout the preceding order, as well as the numerators are also the quantity of shortest pathways passing through vertex 4 among pairs of edges in the preceding order. As for the betweenness measures of the small world network, the outcome is large, suggesting that the property of 6 degree of separation does in fact hold for this type of network. This is due to the larger size and better structure of a network.
With this, the rumor keeps on spreading from one person to another person.
Given a scenario in relation to a small world network about the dissemination of false information about COVID-19. Since, currently the world is experiencing a pandemic, most of the people frequently use online platforms and news to have updates for the COVID-19, but not all of the information in the online platform is true and validated. That is why fake news is timely relevant, where people often do not verify much information that is regarding for their well-being and health.
Summarize. The researchers concluded that the rumor propagated on this small world network spreads faster into the network with the help of applying it to a real-life scenario.
Rumor or an information that is initiated by a spreader in a small world network will continue to spread and disseminate to their friends and acquaintances as quickly as possible after getting the information until the information goes to the person who is ignorant. This part has two possibilities. The ignorant can become a spreader that re-spread again the information, or a stifler that does not care about the information, so the rumor will stop immediately. It shows that the small world network is resulted to have better clustering coefficients, degree, closeness, and betweenness measures. After analyzing and interpreting the data, the network is the most effective for spreading rumors in a small-scale population since it has good numbers of connection.